Wait, we didn't record last week.
For the first hour.
I thought I didn't need to say it. It was live stream and all.
There's your first agent.
Okay, well, take it away whenever you're ready.
Okay. Yeah, I'm closing up some tabs because I'm running on 8 gigabytes of RAM. So if I spontaneously combust, then that is why. Okay. All right. So
a little bit of info as to like what caught your eye as well.
Me?
Like, yeah, we can hear you.
Okay. Yeah, so I'm gonna get into like kind of the motivator behind this paper, and like I'm gonna try to motivate this paper through an analogy. Well, yeah. So as a software engineer, like I'm sure a lot of people here, we code and we depend on packages to develop to basically build what we build. Behind me is my parent and my grandma walking, but all is good. So to compare it to like a software engineer, we depend on libraries to basically not have to reinvent the wheel whenever we're building things. And if we can tap into the libraries that have already been created, then we can basically amortize the work that has already been done, and therefore basically leapfrog into actually building something of value rather than dealing with the like small details of things. And what this paper is suggesting is if much like the software engineer ecosystem of libraries that has been already populated, and we depend on these libraries to build what we build. The action ecosystem or tools that LLM agents use is not entirely developed and is not completely accessible. So what this paper is trying to resolve is that problem, being able to make actions accessible and open up the door for an infinite amount of actions. And how they propose that is best illustrated through this diagram over here. So how this paper works, how this concept works is by first you pass in a task to the agent, and then the agent has the ability to reference either actions or tools that you have passed in as a human, that you have designed yourself as a human, which is illustrated here by AU. And then AG represents the actions that can be generated or retrieved from a database of actions. And so what happens is both of these actions are passed into the agent. The agent decides whether or not it should tap into the generated action, into the action store, and then it retrieves from the action store through the action retriever. It retrieves the actions from using the action retriever, and if there is no compatible actions, then it will generate an action in its place, making it basically indistinguishable whether or not an action already exists in the first place. So and then what it does with that action is it plugs it into an IPython kernel and runs that action with the specific parameters to your specific task, resolves that, sends that back to the agent, and then it just loops over and over again. And here, what the other two blocks here represent is the actions that the human created, but there's no reason why the agent itself could not define the actions that the human could pass in. So that is in essence what the paper is covering. And so I'm just going to go through a couple of notes here that I took. So here they're suggesting that if you're able to retrieve actions from this database, they're also going to be composable. And I think what they're alluding to here, because they didn't provide an actual solution for actually composing multiple actions, or say calling different actions from actions inside the database, what they're suggesting here is that over the course of an agent loop, it can decide to call one action followed by the next over and over again, destructuring the actions into the same destructured tasks, into the same destructured list of tasks. So basically mapping each task into a different action. And because these actions can be generated on the fly or retrieved, it gives you that same level of granularity. So yeah, and this is going to be a common theme. There's a lot of opportunities for expanding this concept and making it a lot more robust. And I'm just going to go through some ideas and some areas that are kind of open-ended. So another thing is, at each step, the agent performs actions by generating Python code. Yeah, so this is basically the general idea. If there is no action that has been already provided by the human, then the agent will defer to generating an action or retrieving an action from the database, which you can just think of as a cache that never misses. At least from the perspective of a human, it's a cache that never misses. But from the perspective of the user. So yeah, and then here they define the terminology of how they designed their agent, and some of the key takeaways is that they are continuously building this action database, and there's like a whole tangent that we can go into regarding like how you can like have a preset database that already consists of like a general realm of actions that you can tap into, and then just build the database on basically a specific domain, kind of like, in machine learning, like fine tuning the database. You want to think of it that way. And then, that's what's being described here by the actions AT representing like the list of actions that you pass. Okay, there's a lot of details here, but in general, it's just a large database of actions that is progressively generated as you utilize it or as you populate it separately. Okay, then while the LLM agent is performing is capable of extending this framework, incorporating tools, human experts, is straightforward. Okay, yeah, here I don't think this is where they. Yeah, so here they mentioned something interesting. We find that combining incomplete. So, okay, I don't remember where they mentioned this, but something that they mentioned was that the human the tools provided by the human are like are used a lot more often than the tools that are generated by the action by the LLM. And the reason why they justify this is because the actions designed by humans, and humans are better, and we actually like put thought into why we created these tools. Like, for example, web browsing, that's something that generally is very useful, and we added that tool specifically to the repository of tools that the model has access to, right? So yeah, they mentioned this somewhere down the line that the human provided actions are used a lot more often than the generated actions, but that I think is by design. We selected them as we think they're going to be more useful, and that the tools that are generated exist just to potentially supplement things later. Then generality. Okay, then they mentioned two things here, which are like the two key pieces of how they're of how this action is how the action is generated, like two hallmarks of what the action generated should represent. One of them is that the actions need to be generalizable, meaning that whenever you're generating an action for one specific task, it should have a high probability to be called in subsequent tasks. And this is something that they actually were not able to resolve during the course of this paper, because it was very unlikely for a tool to be recalled, because the tools and actions that were being created, and by tools and actions, the same thing. I'm just using it interchangeably. The tools are very sparse. They only exist. The tools that are being generated only resolve that specific problem that is that the LLM is currently being tasked with resolving. and therefore is not recalled, meaning that there's a lot of inference, a lot of compute being put into things that might have been able to be recalled. And the other thing is composability, which I mentioned a moment ago, I think, which is the ability for tools to be called subsequently one after the other. Since they are like very atomic in nature, it's not going to create an entire library. It's designed to just like create a small tool, that can be composed with other tools. And let me see if I had anything worthwhile in the notes. Okay. Yeah, okay. Is there any questions so far?
I think just the obvious question is how you compare it to Anthropic's model context protocol.
Model context protocol?
Nathan's asking about like,
I've heard of it.
is this like a theoretical, there looks like there are a lot of equations here. Is there like an actual standard for actions? Is there a GitHub repo that comes with this thing? It looks like you're.
What do you mean by actual standard? There is a GitHub repo. I can share that on. I'll share that now. But I don't think they actually created much of a protocol for like, and by protocol, what you're imagining is some way to like interface with the database to like upload and retrieve.
It's an actual term from Anthropic that made it up.
But the protocol itself.
Yep.
Just ignore the word protocol. It's actually quite similar to what you're sharing.
Yeah, I'm not sure. That's the first time I hear of it.
You should look into it. It's pretty underappreciated. They put out like a tweet and maybe a detailed blog post, but it's a little underrated.
Yeah, actually, I did run into this, but people immediately started like suggesting that it was unnecessary. It was like I don't remember that they were comparing it to something else that was already a lot more developed.
Well, I think you could maybe even like combine this, because I think what this paper is proposing is more of like a database of these actions, right? Where model context protocol is more like a protocol to define a specific action. So I kind of think like they could be like compatible and work together, if I'm understanding this correctly.
Yeah. Well, actually, I'm not sure, but yeah, that's what they're proposing. They're proposing basically a cache. Like this was my main takeaway: a cache for actions. And it's more so a cache for actions is like one thing, and the other thing is just creating like some arbitrary adding an arbitrary action to your list of actions, so that it whenever all other actions are not whenever all other actions are not compatible to like solving the current problem, it'll just defer to this freeform action that will either generate or pull from the cache. I'm not sure if the model context protocol is suggesting anything about what actions should be implemented or how actions should be implemented.
Yeah, MCP is more like if you have an API, it gives you a way to put it in a standard way that you could use with an LLM as an action.
Mm-hmm. Yeah, I'm gonna have to get back to you on this. I just remember they were comparing it to something else, maybe a LangChain or some Lang product that was already defining how actions should be defined, and people are just comparing it to that and saying like, oh, there's already stuff for this.
If you go to modelcontextprotocol.io, I think it has a really good intro. I put it in chat. But...
All right, thanks. Yeah, I'll check it out. Okay. So I guess I'll just continue running through this. Oh yeah, and by equations, there's no equations here. They're just basically like converting a system into like there's no like algebra or calculus happening here. It's just they're converting a chat into variables, a system into variables. So yeah, it's not too deep. But yeah, okay. So Getting back into the paper, they had here they're defining like the action space, which consists again of user created actions, and then the generated actions, which is just the free form action that can be basically any action. And then they mentioned something about we instruct our agent to provide one line. Okay, this is like an area that I feel like could be improved. They use they what they embed into the database is a docstring of the function itself. And this is probably like pretty common by now, but alternatively, you could provide like hypothetical embeddings. You could provide you could embed like the input and output pairs and create a hypothetical embedding for that. There's a lot of different embedding strategies beyond just the one-line docstring that could be implemented into this. But this is not bad. Like they're embedding the docstring as opposed to the function, which makes it more likely to like actually retrieve the correct function. Oh, and contextual embeddings would probably save a good amount of compute with that. Then to enable the agent decide when to invoke action for retrieval. Yeah, so this goes back to like you have a list of human defined actions and like one freeform action. And the way they implement it in their code base is they basically use React. They have a pair of thought and actions. Yeah, basically they just loop over thought and actions, and that's how they implemented it on their side. This is basically building the database over time. The employee actions. Okay, so as for their results, they were comparing to a couple other implementations. I'm not like Sybil's a paper, HF Agent is a GitHub repository, and what's interesting is I don't think that like DynoSaur. So this is something I was telling Swix earlier, but they actually like this paper covers the concept of generating actions and storing them in a database. It doesn't really go very deep into like how the agent actually works beyond what I mentioned here with basically utilizing React. So if you want to learn more about how the agent actually works, then you're better off just looking at the repository. But yeah, so when you actually apply this like dynamic actions database, it performs better than the formerly leading Hugging Face agent and Sybil, which this paper honestly didn't really. Everything was they didn't describe things very clearly, I don't think, but yeah. HF Agent I haven't looked into very deeply either, but it outperformed them on all levels of the Gaia benchmark, where each level is basically it's increasing difficulty. So yeah, they basically outperformed all previous submissions to the benchmark. And then they were also heavily leveraging AutoGen, and in fact the tools that they use for the human actions, like when they were designing, when they were running against the bench, when they were running DynoSaur against the benchmark, the human inputted actions were the same as AutoGen's. So that includes web browsing and basically interacting with the operating system by being able to read files and write files. So and they quite literally, I think they copied and pasted like a file defining the tools from AutoGen and imported it into their repository. And another thing here where they're describing the results of their model after ablating a couple of things, where they define each of these columns as they're defined here. You basically have the initial set of actions. These are the human actions, the actions that are passed in by the human. Then you have the the capacity to implement arbitrary actions. Yeah, okay, so capacity to implement arbitrary actions is actions, the generating actions, and then being able to accumulate actions through an actions database. I don't know why they destructured it this way, because they're basically dependent on each other, in the sense that, well, whether you have AI, like the ability to implement arbitrary actions, generate your own actions, and if you don't have an actions database, then it doesn't really matter. It's just going to generate the same solution that already would have existed in the actions database. So performance shouldn't change. But I think I might be misinterpreting this. I'm honestly like kind of unsure why they decided to destructure things this way. But you can kind of see this the interdependence of these two in the results over here, where yeah, AI and AA. So if you remove like AI, it's basically this is the difference. Like if you're able, I'm not sure how this difference happens, but if you have an actions database where you can store these actions, then it performs 2% better on level 1 than if you basically just generate an action every single time. I'm not sure why that happens. I think I might be misinterpreting these labels, but that's how I understand it. And then another thing to note is here the difference between having the previously created actions versus only generating actions is substantial. Where if you just if you have those predefined actions, those predefined human actions versus just generating every single action, then you end up with basically an 8 percentage difference on level 1 than yeah, on level 1. So yeah, and I was also thinking of another analogy for that, but I won't go into that in the interest of time, in the interest of I'm not very good at communicating my analogies, but yeah. Okay, and they were also using like something interesting that as they were evaluating things, they were basically instructing O1 to handle analyzing the results of the evaluations. So they basically hired ChatGPT to analyze their results, which I thought was kind of funny. Oh, and something here that is notable is that they give this case study, which did receive a good amount of backlash. I think I read it on Hacker News, which made a lot of sense. That they basically created an Excel sheet that consisted of these like colored cells, and the idea was to see to get an agent to be able to navigate this Excel sheet with this prompt, and it seems as if the library that the autogen agent depends on for reading Excel does not have the ability to read the colored cells. And feel free to correct me, but this is what I took away from the comment, is that the library from autogen that uses Excel doesn't have the ability to read cells, and therefore this was basically a completely meaningless case study that they're showcasing here, because of course autogen is not going to be able to solve this if it does not have the ability to read the colored cells. So this is kind of like this is just like an unfair comparison between the generated between using autogen in combination with the generated actions versus just autogen alone. And that's what this is demonstrating here, which is like pretty stark. Maybe this was the idea, just like fill in the gaps where autogen fails. Maybe that's what they're trying to get to showcase here. But it's like a stark failure. It's like autogen had no chance. So that I just feel like that's I don't know, if unfair comparison. And Oh yeah, there is a couple of limitations, as I already mentioned. Tendency to generate actions that are overly specific to a task, so making them very sparse. And they were proposing a solution here, which I'm not sure if I interpreted correctly, but you can read it yourself. But the way I interpret it is as passing in relevant tasks into the original prompt for the action that you're going to generate. This way, it is able to take into account other potential questions to be asked and try to generalize a function so that questions within that domain will then be retrieved as opposed to just be generated every single time. So as a means to generalize actions, you give it a list of tasks as opposed to just a single task to generate an action for. So yeah, that was the paper. Any other questions?
RJ has a question. I'm curious about the. I need a Gaia reminder as well myself. Oh, you actually ran it.
What do you mean?
Is that the collab that where you ran it?
Where I run this is my implementation.
Yeah, awesome.
So I'm gonna share this as well. And reminder Gaia, I can show you that. I have it open here.
All I know is
So
like
and yeah, there
this
was
is why
something I was interested.
Jan LeCun is like everyone else's definition of AGI is wrong. My definition of AGI is correct. This is the benchmark to solve if you want to make me happy.
Yeah, they're hard. Like read this thing. I actually I don't even know where to start on this one. Like this actually seems incredibly hard and it's level 2.
Okay, so it needs like web access.
It needs web access. You need to be able to find a specific table, which may or may not be in markdown format. Maybe it's an image. You need to be able to get the two axes and then extract from those axes some information to then query archive again to retrieve a specific paper from physics. And on top of this, like you're talking about finding a paper in the entire month of June 2022. So yeah, this is rough.
What actions are available to solve this thing? Like I think you need vision, and I think you need a web browser. I think you need search. And you might need a file system.
Assuming if there's
Yeah.
not even cheating the search, like let's say someone like fed the search answer, it needs to go through every paper in June.
Yeah, that's what I was thinking.
Yeah, it needs to be able to branch into multiple subcontexts.
So it needs to go through every paper and then be able to identify the specific one that has those.
It's either needs to be able to
Yeah, it
handle
is not easy.
context or branching, which is both are not easy.
Yeah, no, this seems to like at least a 20-minute activity for me if I'm locked in. And that's what I've heard from this. Like people spend around like 10 minutes for a level 1 problem. So
I'm gonna put this in deep research. Give me 1 second. So Google has this deep research thing that they launched. Can you put it back on screen? Okay, I'm gonna grab it. Oh,
yeah.
no, I lost it. Put it back on screen. Okay, got it. Okay, cool. Google has this deep research thing that they launched that I can try.
When did they launch this?
Last week.
Ooh. Yeah, no, they made an announcement about agents, which sounds interesting, but I don't think they actually like. They're just alluding to some product that they're going to release.
About AI regulation. It was originally archive.org in June 2022, 3 axes. Which of these?
Oh, and I can actually check the
Oh,
answer.
which of these words? So there's a subset of words. Let's see. Oh,
interesting.
which of these words? What words? Okay, so
egalitarian is the answer.
I know the answer, but like there are two dates here. There's June 2022 and then there's August 11, 2016. So which one is it?
June 2022.
So why is the question about August 11, 2016?
Oh, that's a different one. That you got to find another paper
That's
using
confusing.
the information from June 2022 paper.
Oh, it's a two-part.
Yeah.
Fuck. Okay.
Damn. Swix didn't pass the AGI test.
I failed.
Yeah. Yeah, so you guys can try these out. They're rough. But yeah, I just want to wrap things up. So here's basically my implementation of it. This one's using structured outputs and it's intended for like deployment or development. Whereas what they released is basically just for research purposes. It's just a bunch of it's a lot of scripts. But so there's like two things that I did want to nitpick from their repo. One is that one it's scripts, it's not designed to be deployed, and two is that they were not using they were not using structured outputs, which meant there was a lot of retries. So it would take a long time to like actually generate a form in action that would actually be effective. And on top of that, they needed to do a lot more prompt engineering. So that's basically the two differences here. You basically begin by importing this action collective package, and then you just then you just instantiate a class and execute. Yeah, you just pass it the chat history, and it generates or retrieves an action, runs the action, and then gives you a summary. So this illustrates just the entire flow, assuming that the action is needed. And what happens here is it retrieves the action. I've already ran this like several times, so it actually did retrieve an action. And then it generates the parameters and then generates a summary towards the end, which is then validated against actually running the like dot product of a sequence of numbers, which I changed a couple here and there to make sure that it is not very easily solvable. And here's like the true the matrix result is the true result, and it just compares it against the summary and it passes that. But that is not how you would actually use this. You would actually want to integrate this into an agent that you have already defined, and that's what this script here shows. So here you're basically fitting it into a ChatGPT into a ChatGPT chat completions flow, where you've already defined the previous a previous tool. In this case, I defined the web browser tool, a web browser tool that is using SERP API, which is using the Google browser. I added that tool somewhere. Where did I add this? Where did I add this? Okay, tool. No. Chat history, web browser tool, Okay, right here. So here are the two tools. Here's the action collective tool. And then the web browser tool. So there's a couple of prompts here. I gave it the original, the same prompt that I gave it before, where I forced it to use action collective. And again, well, it gives you the result right here is this, and then the final number is like 1775. Yeah, 1775. And then if I change the prompt to something that doesn't use any of the actions, it will not use any of the actions. So if we change this, then it'll just be a quick generation and it's complete. Hello, how can I assist you today? And if we decide to give it like a web browsing challenge, like what is the stock price of Amazon, it will not use action collective at all. So this just demonstrates the different that an actual use case of when you would use action collective. And just to well, okay, it seems to have given sometimes it's able to actually get the stock price. But the idea here is it wasn't actually using action collective, or it shouldn't have been. Is it? If I do verbose here, I'm actually going to know for sure. What is this price? Okay, it is verbose. So it did not use it. If it did use it, it would have a lot more. It would print a lot more things. So either my SERP API key is not working, or either my SERP. Yeah. So here's the logs that you get if you do end up using Action Collective. So it was working. It was something with the SERP API tool that made it unable to like actually return Amazon results. But again, the key takeaway here that from the paper, I think, is one, it provides a means to have a basically unbounded an unbounded action that can basically take the form of any action you need it to be. And it also illustrates this idea of an action cache, where as opposed to generating actions over and over again, meaning resulting in a lot of wasted compute, you can just tap into a vector database to store the actions so that they can be reutilized in the future. And I think that there's a good amount of potential if you just think of the analogy of creating like a package, a library index for actions that is like available for everybody to use, and then you can possibly extend this for like a very domain specific challenge where you could basically just fork a populated action collective with, like, let's say thousands, millions of actions, and then basically just give it a list of tasks inside of a domain and have it generate actions within that domain. And you're basically fine-tuning the actions. You're basically fine-tuning this database onto your domain, and you can basically just develop agents without actually having to like write any of the tools. So yeah, that's DynoSaur, and then my version of it, which is Action Collective. Do you guys have any questions?
No, I think that was a really kudos for actually trying it out and doing a proof of concept. I'd love to, if you can share that code, that'd be great. I think for folks.
Yeah.
Let's move on to Ramon's presentation.
All right, thank you.
No, I was running it in deep research, like Gemini deep research, and it's found the answer. I don't know if you saw
it. Did?
Yeah, if you want me to screen share, I can screen share. I don't know if everyone has access to deep research. I got access because I'm part of the tester program. So
you mean like the correct answer is in the list of links it gave you, or actually?
No. I asked it to give me the correct answer.
So, that's sick.
Yeah, so here I pasted in from the screen. Can you see my screen? You can see my screen?
deep research is available for the Pro.
Yeah, so it's just a drop down. You get deep research and stuff. If you can see my screen, I just pasted in exactly word for word what Sebastian had. It came out with a list of sources.
We see all your keys. Can you?
Yeah, I think you shared the wrong screen. All your secrets are on.
My what?
You probably have two screens and you're sharing the wrong one.
Don't worry, we took screenshots of
your Anthropic API key.
Oh boy.
Yum.
Need to cancel that one.
Time to reset the API keys.
Yeah. This one? Okay. Let's see. Cool. Yeah, I need to cancel that one.
Okay, now it's right.
Cool. Yeah, so I pasted in his question, and then it searched those exact terms. I think it maybe it's like skipped a few steps, but even the first answer was already here inside of the first response. And so it did a little summary. I thought the summary was pretty good. So the summary is over here. And it opens it in a doc or like Google Doc or something. Oh yeah, so it just like gives a full report, and it really like reads the questions. But I don't really care because it found the right keyword, egalitarian and hierarchical. And then after that, I asked.
But which one is it?
I asked it to just give most likely one word answer to the question. What are the words used to describe? And it just gave it egalitarian.
Oh, it did.
Yeah, so it's solved. So
I'm how did they perform on Gaia? Did they ever like run it against the benchmark?
No, Yeah, I don't think Gaia is a very popular benchmark. Basically, only Meta brings it up. Yeah. Cool. Let's move on to Ramon because I don't want to.
But, okay.
But yeah. And I'm gonna go rotate keys. Woohoo! Delete keys.
Sweet, can everybody hear me fine?
Yep, you're great.
Yeah, good.
So I was thinking maybe it would be better to move mine to the next one, just because I genuinely don't think I can try to make a justice in 15 minutes, but there's a bunch of stuff that if you have never done model merging, I think you might find unintuitive. So I created this long ass notebook and I explained from linear interpolation to the two base methods that they use to be able to do parameter space merging and then the data flow merging. And then I created all these diagrams to be able to showcase like what exactly is happening. So I think 15 minutes is definitely stretching it. I also have a couple of implementations of it, and I don't know, maybe it's better to
Let's move.
Yeah.
I'm open to moving it, but also next week is Christmas. I don't know if you
yeah,
want to
not
do
next week, but after that, because yeah, like obviously like we're all off next week. There's even so there's
I'm not.
Actually, I was about to ask the elephant question. Are we doing Papers Club on Christmas?
Yes,
I don't mind. It can be a special.
I will run. You're doing.
But yeah, if we can put it on the first week of Jan or second week of Jan, like whenever the next one is, because yeah, like I can try and go through it in 14 minutes, but and then I gotta run at because it's 8 a.m. for me in Sydney, and so yeah.
Yeah. I am down for separating it out. The previous paper went more in depth than even I expected as well. I also do request that you do one of the merge live.
Sorry, say that again.
Can you do one of the merge live, because you should be able to do a merge in within that time.
Can I do a merge live? Sorry.
Yeah, during the presentation.
Oh yeah. No, that's the whole plan. Yeah.
Awesome.
Wow,
But maybe,
that's exciting.
do you want to do like the high level stuff without notebook this time in like 10 minutes? And then let's tell everyone to read the paper next time and go over the notebook so more people are prepared. But do you want to just do
Yeah.
high level for 10 minutes?
Yeah, let's do it. Let's do the high level. So okay. So let's go over here. I'll add the notebook to a repo and also my notes on the to the same repo so that everybody can see it. But the main idea behind this paper is that, and actually let me give you the motivation before I even tell you the main idea. So when you have all these compressed models in small parameter sizes, like 1 billion, 7 billion, and even 70 billion, you have a bunch of layers that probably activate in different ways or that probably have different kinds of meaning in them. So when you merge, when you want to create new models, instead of having to either fine tune a model and having to spend a lot of GPU resources, then your best bet might be to merge two different components of them. So, and by merging, that means that it can be the parameters that you merge. So that they actually have a great visualization here where you can take a block of one particular space, put it into a completely new model, then create merge blocks from model A, model B, model C, and then also add it to the new block. So because two blocks might influence what happens into the decision of the next token, for example, sometimes specific blocks, you want to keep them right next to each other. And sometimes like you can interleave one in the middle of the two. So in the paper, what they do is that they take different versions of Mistral 7Me models and they merge these models with another a Japanese-based LLM that they train They create their own evaluation data set, and then what they try to do is, can we take a model that is very, very good, is small and very, very good at math, and then merge it with a Japanese one, and then start asking questions in Japanese and get the right answer, the right math answer. So that's one. And then the other one is, can we take an LLM that knows a lot about a lot of cultural facts of in Japanese, and then combine it with a vision model, and also with a different LLM, and then create a new model that can understand images that are very culturally specific to Japan. So there's a couple of things as well that are very important to understand. Like, this builds on very good work on different algorithms for doing model merging. One is task arithmetic. I have an example of that, TS merging, and then the DARE method. All of this kind of like put together different pieces of models and then make a complete new one. And then the one that most people are using nowadays is called Franken merging, which is not based in weight merging, but it's for the user to experiment with trying to stack different layers from multiple models, sequentially creating new ones. So what's the catch here? The catch is that when you try any of these methods, you might have to do 100 iterations and then do a little bit of vibe check. Is it working correctly? Is it not? Did performance drop in a specific place or not? So that can take you quite a while. And they call it in the paper a bit of a black art, I think it is. Yeah, so it says it's required. Model merging is considered by many a form of black art or alchemy, relying on model makers' intuition and instincts about the model selection, the merging recipes, and so on. So what they do is that they apply an evolutionary algorithm to try different combinations of parameter space, data flow space, and the combination of the two. So if we go to this chart over here, you're going to see that it's a little bit confusing that the X also has a green, but they ask two questions here in this example. Mishka bought 3 pairs of shorts, 3 pairs of long pants, and 3 pairs of shoes. How much were spent on all clothing? Also, bear in mind that maybe the translation seems a little bit off, but they do say that here they translated the question to English from Japanese text. So that's probably why it kind of like reads weirdly. Cynthia eats 1 serving of ice cream every night. How much will she have spent on ice cream after 60 days? So the first one is the one where you merge at the parameter space. So you combine the weights with specific methods. They use a threshold of 50% from one, 50% from another model. And then the second one is the data flow space, where you merge the layers rather than the parameters. And then in the last one, you have both. But instead of taking a block and putting it in the new one, you merge different models. You create a different complete model, and now you have a whole different set. So if you have model A, model B, model C, you merge a new one, create model D. You merge another one, create model F or G, and then you put all of these ones into this bucket of models, and then you create a third one, which is meant to be the best one out of all. Then they test this on a data set that they created themselves with about 250 problems. And then in this particular visualization, they go over how well it did answering Japanese questions. And then the ones at the bottom, hours, parameter space, hours, data flow space, and then hours, combination of the two, has the most amount of answer correctly questions. So in summary, or because this is a high level explanation, the paper goes through, can we get rid of having to experiment hundreds and hundreds of times with merging different models? And can we find a better way of finding the best way of merging specific models? This reminds me a little bit of, I don't know if any of you ever played around with Teapot. Teapot was, or is, I think is still under development. I'm not 100% sure, but it's a way of creating AutoML models, and it uses a couple of evolutionary algorithms to be able to find the best combination of parameters. And so this is kind of like what it reminds me of. The use of tuna and something else in their code to be able to go through this. But yeah, so I'll leave it there, just because I know that there's a lot to cover in it, even though it's a short paper. There's a lot of background knowledge, and I really like it. I think it was really cool, and I think they're definitely up to something. So yeah. Any thoughts, questions?
Very fast recap. Do you think that this is a one-time thing, or you will adapt it for domains? Yeah.
So if I had to, I don't think this is a one-time thing. Honestly, like, so the reason I stumbled upon this and the reason I wanted to talk about it was because I'm experimenting. So my first language is Spanish. So I was experimenting with like, how can I get like the best performance in a smallish model? Because if I go to ChatGPT and I use GPT-4o and even GPT-4 mini, or I use Claude, Haiku, or the latest Sonnet, it still does pretty good in a bunch of very basic Spanish tasks. If you get a little bit more complex, it might not do as well. So I wanted to experiment with this, and I think this is a step in the right direction to maybe not necessarily potentially become the sensible default of creating smallish models for very bespoke tasks, or a little bit more powerful smallish models. So for example, this past week, the CEO of Hugging Face, Clem, said that released that they made a Llama 1 billion reach higher levels of accuracy, or achieve a better score in different benchmarks than the 7B of the Llama model. So that could also be really cool. Like if you use this evolutionary merging recipe and then you retrain the model to, like, I don't know, go over the output again and think again. Maybe that might be the actual combination: evolutionary plus evaluate your answer and then answer again. So
Yeah.
I have a question. I believe there is two ways to see different solutions for this problem. I like to think there is the anthropic way, which they try to solve this inside the model, right? There is like a more powerful model that handle multiple languages and stuff like that. And I feel that there is a agentic way to solve that problem as well. My first language is Portuguese, and I struggle with the same issue you have, Ramon. And what usually we do is we always have a first model that is answering questions in English, and then we have a second smaller model only specialized in translating. And I think there are like upsides and downsides. It's like a trade-off of both strategies. I would like to hear from you and other people here their opinions about those two possible ways to solve the solution.
okay, so this is an excellent question. So the reason I am like researching smallish models is because I'm more thinking on the terms of on device. So if we're thinking about server client architecture, then yes, the Agentica approach is probably going to be the best suited one, because now you have two models and you have them on the server, and the user doesn't need to care about the computational complexity of running two models, maybe three, maybe four, maybe five. But if I have the models on device, then I definitely want the most capable one that can potentially fit in one machine or in a cell phone and so on. So I think that's the angle that I'm taking here. What's the most powerful model that I can get for an on device that can also understand the nuances of a different language? Like I can imagine, since you speak Portuguese, Portuguese from Brazil versus Portuguese from Portugal is going to have different nuances in the language. It's the same for me. I'm from the Dominican Republic, and when I talk to people from Spain or I talk to people from Argentina, like it's absolutely different, the nuance there. So can I have the best model on device, say for example from people from the DR versus people from Mexico, or for people from Mexico, or for people from other places and so on. So yeah,
Interesting.
Sorry.
Did you check the Apple Intelligence paper?
Did I check
the Apple Intelligence paper?
No, I haven't.
Yeah, so I was debating about this paper. I didn't read it, but I have a friend. He has been working with that the paper, and they talk a lot about like how to solve this paradigm about like server requests versus embedded. And the way they solve this is they have a smaller version inside the device. They have a bigger version on the server, right? And then there is the problem of, okay, if the server updates, how do I update the embed? And the way they solve this is through I'm trying to remember, but I think stuff is similar to LoRa adapters. So literally what you can have is you could have one single model in your device, but you could have different adapters. So then the model has different tasks. I have no idea exactly. I didn't read this paper. I'm just throwing at you because maybe it's something that can be helpful.
Yeah, this is great. And also, sorry, I didn't get what's the name of the paper again?
I'm gonna get the paper here and I'm gonna send you the link. Just 1 minute, please. Okay.
Okay, no problem. Yeah. Any other questions, anyone?
I guess not.
Okay. Okay. So the link is in the chat, and I think it's a great paper. I'm gonna have a good look at it.
Oh, the Apple Intelligence paper.
Yeah.
Great. Thank you for sharing.
Yeah.
So just a quick question. So Ramon, the idea behind the paper is you like merge the weights of two different models. Well, just one thing to like, can the weights of the models be of different sizes, or do they necessarily need to be of the same size?
This is great. So I was actually covering this as well in some of the diagrams. So you can have models. So with the Frankenstein, I think the biggest thing with the Frankenstein is that you can actually get models of different models of different architecture. So, but then with the other ones, with the TS merging, like they have to be of the same architecture. And in the paper, they use all of the models that they use. I think there's about 5 or 6. All of them are fine tunes of Mistral 7V, V0.1, I believe they were. So depending on the approach, to answer your question directly, depending on the approach, the models have to be of the same architecture. And if depending on different approaches, then they don't have to. Like you can create even bigger models by just stacking a bunch of layers. It's just going to increase the inference time.
Interesting. I'll save the other question for when you actually present.
Okay, sounds great. All right. Well, thank you, everyone. Thank you for sharing the paper earlier as well. Very nice, very cool. And yeah, I'll see you in the next one.
Thank you.
One
Thank you, Sebastian. Thank you, Ramon.
Christmas episode coming up. We'll figure out what that is. Bye.
Bye. Thanks. Bye.